Alright, in this video I'm going to go through classwork integration, long division, and completing the square. So we're going to cover u-substitution, long division or synthetic division, partial fractions, and completing the square. And let's get started. So number one, for the first page here, all we're going to do is some u-substitution. So we want u to usually be the thing that's found inside of another function and that we can take the derivative of easily, and hopefully that we see that derivative somewhere else. So hopefully you have an idea of what our u is going to be. In this case, it's going to be the bottom. We're going to let u equal the denominator here, x squared plus 5x plus 10. And when you do u substitution, you need to solve for du as well. So du here is going to be 2x plus 5, which is exactly what we see in the numerator here. So we got the 2x plus 5 in the top, and I should also write dx here. So wherever I have 2x plus 5 dx, I can replace that with du. That allows us to rewrite this, and the 2x plus 5 and the dx, that's going to get absorbed into the du. So then we're just going to have 1 on top, and all this on the bottom, the x squared plus 5x plus 10, that's going to become u. And now we should be able to integrate this, take the antiderivative with respect to u. 1 over u, the antiderivative is going to be natural log of the absolute value of u. And if you want to, you can just simply replace the u right away as x squared plus 5x plus 10. And we need the absolute value bars here because as long as this x, the inside here, can be negative, we need to make sure we have the absolute value bars. If we're sure that the inside is always positive, then sometimes we will drop the absolute value bars and just put parentheses. But in this case, x squared plus 5x plus 10, there's going to be some places where that could be negative. And don't forget the plus c at the end. So that's all we have to do for number one. Again, we're going to start with some u substitution. This one's a little bit different. What do you think we want u to be? Well, again, it's going to be the bottom. So we're going to say u is equal to x plus 3. And as you find u, also find du. du here is simply the same as dx. So where we have the dx, we're going to have to replace that with a du. This x plus 3 is going to get replaced with u. But then we still have x plus 6. And we want everything to change from x's into u's. And so how can we rewrite x plus 6 in terms of u? We can take this equation and solve it for x. And we would have x is equal to u minus 3. And now I've got the x by itself, but I don't want just x, I want x plus 6. So if I add 6 to the right side here, then I can add 6 to the left side here, and I would have add 6 to that, so I'm going to have u plus 3 is equal to x plus 6. So now we can transform this and rewrite this equation. So where I have x plus 6, I can write u plus 3. Where I have x plus 3, I can write that as u. And where I have the dx, I can replace that with the du. You might think, well, that doesn't look any better because it's still a fraction. But when we have multiple terms on top divided by one term on the bottom, we can rewrite that and divide everything in the numerator, every term in the numerator, by the denominator. So we can take u divided by u, that's just 1. 3 over u, we're going to write as 3u. So we want to change it from one fraction and then write it as multiple terms here. And now we can take the antiderivative of each term as we see it. So we can take the antiderivative of 1, which is just going to be u. We can take the antiderivative of 3 over u, which is going to be 3 natural log of the absolute value of u plus c. And even after you do this, we're going to have to replace it. So wherever we had the u, we're going to write x plus 3. So x plus 3 is going to take the place of that u. Then we have plus 3, natural log, absolute value, x plus 3. We still need the absolute value bars here because this could be negative, plus c. And if you look at the answer key, it doesn't look exactly like this. And the reason for that is because this c, remember, means any constant. Anything that's being added, just subtracted, any number. You know, plus c here could be plus 10. It could be minus 13. But we have this other additional constant. So usually all the constants we just absorbed into one constant. So the 3 and the c together is just going to be some other constant. So we're going to put this together as plus c here at the end. So that 3, that c, becomes a new constant, which we're just still going to call c. And we have x plus 3 natural log absolute value of x plus 3. So that's the way it's going to be written. If you wrote it like this, then you still have the correct answer. But again, the 3 and the c here is just going to be absorbed into a new constant, c. So we're looking for this for our final answer. For number 5, we got the same idea going on here. What are we going to let u equal? U here is going to be x plus 2. Du is the same as dx. And now we need to rewrite 3x minus 4 in terms of u. So first thing we want to do is maybe solve this for x. So we get x is equal to u minus 2. And now we want to write this as 3x minus 4. So we have to multiply both sides by 3. I'll do this in a couple steps. Eventually you'll be able to do this maybe in your head. So multiply both sides by 3. You're going to have 3u minus 6 is equal to 3x. And then we need to take 4 away from both sides so that we get this to match up. So take 4 away. That's going to give us 3u minus 10 is equal to 3x minus 4. And now we can see wherever we have the 3x minus 4, we can replace it with 3u minus 10. And we've got everything that we need to do to make our replacement, to make our substitution. So where we have 3x minus 4, I'm going to write 3u minus 10. Instead of x plus 2, I'm going to write that as just du. And the dx, that's the same as du. So we've got du here at the end. Now we've changed the integral from this in terms of x into this in terms of u. And again, we want to maybe think of this as dividing everything by the bottom, divide everything by u. So that's going to be 3 minus 10 over u du. Take the antiderivative. The antiderivative of 3 with respect to u is going to be 3u. But u here is x plus 2. So I'm going to just put it in there right away. So that's going to give us 3 times x plus 2 minus the antiderivative of negative 10 over u is going to be negative 10 natural log of the absolute value of u. Again, u is just going to be the x plus 2 plus c at the end. And we can simplify this a little bit further. So if we distribute here at the beginning, we're going to have 3x plus 6. So we're going to write down the 3x. The plus 6 is a constant, which will be absorbed with this c at the end to give us our final constant. And so we're just going to write down the rest of it. Negative 10 natural log x plus 2. Again, we need the absolute value bars there. And then the 6 that was there plus the c is going to give us a new constant, which we'll just call c. Okay, for number 7, again, we do u substitution. So you're going to be doing u substitution until you get to number 11. So here, let's let u equal, what do we let u equal? X minus 4. Okay, du is simply dx. Now what? Now solve this for x. So x is equal to u plus 4. And we don't want just x here. We're going to have to replace the 2x plus 5. So multiply this by 2. That's going to be 2u plus 8. And then 8 plus 5 is going to be 13. So I'm just going to put that right away. That's going to be the same as 2x plus 5. So notice I did 2 steps to get to this. So you can do those 2 steps in your head. Just write down what you got so that you remember when you go down to here. And we're going to rewrite this. So where I have 2x plus 5, now I'm going to write 2u plus 13. X minus 4, that gets replaced with a u. Dx, that's going to get replaced with a du. Now we're going to split this up. So let's write this as 2u divided by u is just 2. 13 over u du. And we can now take the antiderivative of each of these terms. The antiderivative of 2 is going to be 2u. What is u? X minus 4. This is going to, the antiderivative of 13 over u, that's going to be 13 natural log absolute value of u. What is u? X minus 4 plus c. Simplify it. distribute here. That's going to be 2x minus 8, but the negative 8, you can think of as being absorbed into the constant. So we're just going to put that at the end. And then we write down the rest of it. Natural log, absolute value, x minus 4, and the negative 8 in the c gives us the c. Number 9, the antiderivative of 4x minus 7 over x plus 3. Already guessed it. U is equal to x plus 3. du is equal to dx. Solve for x. U minus 3 is equal to x. Get it into this form. So we're going to multiply this by 4 and then subtract 7. So we're going to have 4u minus 12, subtract 7 from it. So 12 minus 7 is going to give us negative 19. And that's going to be the same as 4x minus 7. So multiply both sides by 4, then subtract 7 from both sides. And that's going to give us 4u minus 19 is equal to 4x minus 7. Substitute. Rewrite the integral. So on the top, instead of 4x minus 7, we're going to write 4u minus 19. On the bottom, instead of x plus 3, we're going to write u. Dx, we write du. Now, simplify it. So, divide everything by u. That's going to be 4 minus 19 over u, du. Take the antiderivative. Antiderivative of 4 with respect to du is going to be 4u. U here is x plus 3. Minus 19, natural log of u, which again is x plus 3. Plus c at the end. 4 times x is 4x. 4 times 3 is 12. The 12 will get absorbed with the rest of the c. And so we have the rest of our answer, 4x minus 19, natural log, x plus 3, plus c at the end. So starting with 11 here, we have to do some long division or synthetic division. So long division / synthetic division. And the reason why is because, well, now the numerator is a higher degree than the denominator. So we're not going to be able to use the same trick. If you look at the ones above, it always happened that they had the same degree, they were both linear, and we could do that kind of u-substitution. Here we cannot. So we want to take the top fraction or top polynomial and divide it by the bottom polynomial. You can either do this by long division or you can do it by synthetic division. Synthetic division is a little bit easier because you just keep track of the coefficients. So to do synthetic division, you're going to write down the coefficients of your numerator. So here it starts out with a 3, and then the next term would be negative 1, and then the next term would be negative 17. Those are the coefficients. And then you're going to make a little box here, leave some space to write some numbers, draw a line. The number that goes in the box is going to be the 0 of the denominator. So usually if this says x plus 2, when is that equal to 0? That's going to be equal to 0 at negative 2. So even though it says x plus 2, we're going to switch the signs. If you remember from long division, we would write out the whole polynomial, and then outside the division box we'd write x plus 2, and you would have to divide and then multiply, and then you would have to subtract the terms and change the signs. If you put the negative, if you change the signs right now, you're not going to have to worry about subtraction. So that's why we're going to put negative 2 here instead. This is the setup. So again, we got the coefficients here, 3, negative 1, negative 17. And if this says x plus a number, we put x plus a, we put negative a here. If it says x minus 2, we would put positive 2 here. And now when we go down, we add. And when we put a number up here, we're going to multiply. So going down, we just bring down the 3. And then we multiply. The number that's in the box times this number is going to go up here. So negative 2 times 3 gives us negative 6. Add going down. So we get negative 7. Multiply. The number in the box times this is going to go up here. Negative 2 times negative 7 is going to be 14. Add going down. That's going to be negative 3. And we just divided. These are the new coefficients of our answer. Since we started out with an x squared and we divided by an x, the polynomial is going to go down by 1 degree. So if it started out as a quadratic, now we're going to have a linear. So this represents 3x minus 7, and this part right here is going to be the remainder. So the last number is always going to be the remainder, which you're going to write as a fraction over the denominator, over the divisor, in this case x plus 2. So this integral we can rewrite as this integral. So we just divided these polynomials, and now instead of having it as a fraction of polynomials, we have multiple terms here. So here we have 3 terms, and we can take the antiderivative of each of these. The antiderivative of 3 to the x is going to be, bump it up a power, 3x squared divided by 2. And the negative 7, bump it up a power, is going to be negative 7x. This should look familiar. You could do a u-substitution, but eventually you realize that these all kind of follow the same pattern. The pattern is that if you have to take the antiderivative of a over x plus b dx, if you have to take the antiderivative of that, it's always equal to a natural log of x plus b, like so. So this is like a little shortcut. So once you see this, you can just say, oh, I know what the antiderivative of that is. It's going to be negative 3 natural log of the bottom x plus 2. Because u here would be x plus 2, du would be the same as dx. And so you do that u substitution, take a little shortcut, and you can just write it, right away. And there's our answer. Okay, number 13. Again, we're going to do long division. So we're going to do this by synthetic division. Let's set it up over here. So we're going to write down the coefficients. So 7, negative 38, 6. So you got to make sure that you're counting for every single term here. Here's our x squared, here's our x, here's our constant. What's going to go in the box? Since it's x minus 5, the 0 for that is going to be at 5. So you're just going to put a 5 there. So whenever it's x minus a, you're going to put a there. Leave a line, leave a space, draw a line, bring the first number down. So remember, you're adding going down, you're multiplying to put the numbers back up there. So 5 times 7 is going to be 35. Add going down, that gives us negative 3. Multiply to go back up, that's going to be negative 15. Add going down, that's negative 9. The last number will be your remainder. And when you're doing long division, the power is always going to go down. As long as you're dividing by x squared and you divide by x, it's going to go down by 1. So we can rewrite this integral as the integral of 7x minus 3. And then this part, the remainder, we're going to write as a fraction over the denominator, or the divisor, of x minus 5. Now that we have it rewritten, we can take the antiderivative. So this is going to be 7x squared divided by 2 minus 3x minus, this part is going to be 9 natural log of the bottom x minus 5 plus c. Synthetic division, again, so for some extra practice, write down the coefficients. So you got all the coefficients here, 3x squared, 14, 9. So 3, 14, 9. What goes in the box? Negative 2. Leave a space. Draw a line. Synthetic division. Bring the first number down. Multiply. And then add going down. So 14 minus 6 is going to be 8. Multiply. Goes here. 9 minus 16 is going to be negative 7. This part is the remainder. Rewrite. So we can now rewrite this as the integral of 3x, just 3x, plus 8. And this is going to be minus 7 over x plus 2 dx. So these are the same thing. We just did the synthetic division. And now, since we have it written as a sum or a difference, we can take the antiderivative of each of these terms, and that's going to give us 3x squared over 2 plus 8x minus 7 natural log of x plus 2 plus c.